Alright, so in this video we're going to be looking at day 1 of 2.1, using graphs to relate to quantities. And so our objective as well, we're going to be using graphs to relate to quantities. So the first thing that we're going to be looking at is that a graph shows the relationships between two variables. Those variables we use to label the axes of the graph. So for example, we have this problem right here where we have the graph that shows the amount of gasoline in Jamie's car after she fills up her tank. We want to know what are the variables and describe how they're related at various points in the graph. And so the variables are, as we said here, the ones that are used to label the axes of the graph. And so in this case we have time and gas. Now in parentheses this is the unit of time and the unit of gas. But our variables are time and gas. Those are the variables that are being related in this situation. And so we want to describe how they're being related at various points in the graph. And so this graph right here is describing or showing the amount of gas in the car over the course of the days. And as we can see over the course of the days, it is going down. And so overall, we can say that she is using her car, because as she's using the car, the gasoline is getting used and the amount of gas in the car is depleting. At the very beginning, this is where she fills up the tank. And we just want to describe what's kind of happening. Now, as we can see, we have some parts where we're going down slowly. Here, 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 and other parts where we're going down a lot more quickly, so there and there, and then other parts where we're actually kind of staying flat, there in yellow. And so we want to kind of describe maybe what's happening at those different points. Well, at the red points, when we're going slowly down, so when we're going down slowly, she's probably using the car, but using it very little. She's only using, maybe we can say using the car just a little bit. Maybe she's just going around town or just taking care of some errands or doing something just a little. In the places where it's going down quickly, this is probably where she's using the car a lot. Maybe she had to take a trip out of town, go quite a far distance. Maybe she, had to drive to Vegas in a day or something, to really get out there. So using the car a lot. And then the places where she's, going down very slowly, here and here, or actually not going down at all, it's flat. So places where it's flat, do we think she's using the car at all? Probably not. And so we'd say not using the car. Okay? And so we're kind of just describing what's happening at those different points in the graph. It fills up there. And so that's kind of what we're going to be doing. If we are given graphs like this, we want to identify the variables, what's being actually related here, and then what's kind of happening at each point. What does it mean if it's going down slowly? What does it mean if it's going up slowly? What does it mean if it's flat in the context of the situation? So that's kind of what we're looking at in this lesson. And so we have this next one here where we're blowing up a balloon. So this graph shows the volume of air in a balloon as you're blowing it up until it pops. And so we want to know what are the variables. So again, our variables are on the graph, time and volume. So that's what's being related. Variables are time and volume of the balloon. And so we want to kind of know what's going on. So we have a couple different aspects of the graph. We have these places where we're going up, and it looks like it's about going up steadily about the same same rate of change as it's going up every time. We have some places where we have flat parts again. And then we have this part where it just shoots straight down. And so we want to, in the context of our scenario, we want to know what's happening. On the parts going up, we are probably blowing up the balloon, or the volume over time, the volume is getting larger. So that means we're blowing air into the balloon at that time. So when we're going up, we're actually blowing up the balloon. So what do you think is happening when we are flat, in these flat areas right here? Time is still going by, but the amount in the balloon isn't changing. It's kind of gone up to a certain level, and then it stays that for maybe a second or so, and then it goes back up and stays the same for a second. What do we think is happening? As hopefully you thought, this is probably where we're taking a breath. Because we can't just, we don't have an infinite supply of air in our lungs, and so we have to take that breath as we are blowing up the balloon. We blow it in, take a breath, blow some more, take a breath, blow some more. And then what happens at this part? Suddenly shoots back down to 0. The amount in the balloon suddenly drops very rapidly down to 0. Well, if we look back to our situation, what does it say is happening? Until it pops. And so this is the place where we are where it pops. And so that is our very quick decrease. Very quick. Let's say very quick decrease. Or the drop, however you want to kind of describe what that is. That is when the balloon pops. All right, so again, we identified our variables in the situation. We described what was happening as our at the different points in our graph, and that is kind of how we would take these type of problems. So there's a few more problems in the notes. So this one here, we are kind of flat, then dramatic, quick decrease, flat, quick decrease. And so we're thinking about the situation that it's a board length over time, maybe what's happening to the length of the board each time that quick drop happens. And so there's that one. You have a few other problems here. Cell phone cost. Can even change minutes to maybe data if that might make more sense to you. Your data usage. That might make more sense than minutes of calls with the kind of phone plans that we have right now. A couple practice problems there. So on each of those problems, you're going to do the same thing that we did. You're going to identify the variables and then describe the different points in the graph, what is happening at each of those points. All right, so just as graphs, we can also relate variables using tables. And so often we use graphs to represent the data from these tables. And so we're going to go ahead and do that. So this situation is that a band is allowing fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph would represent the data, best represents the data shown on the table. So we have these different choices, kind of like a multiple choice problem. We have these 4 different graphs here, A, B, C, and D. We only have one graph. So we want to look at the data in the graph and see, okay, which of these graphs would make sense? Well, first off, very quickly, we can see as the days are going by, is the data going up or going down? Well, I should be able to see very easily that it's going up. So right away, I can eliminate D, because D, my data is going down. It's decreasing at that time, and so doesn't really make sense for the data that I have. So I know it's not D. Now for the other ones, all of them are going up. If we look at the first one, this one is going up at a steady constant rate. It has a constant rate of change is what's going up. This one is going up. It kind of goes up a little bit and then a lot more and then goes up really quickly. It's going to be a very quick rate of change. It's not constant. It's changing, but changing very rapidly. Rapid, maybe we can say that's a rapid increasing rate of change. Whereas this one right here is still going up, and it seems to go up quickly at first, but then kind of slows down. So we can say rate slows down on that one. So it goes up really quickly at first, but then starts to, taper off, slow down, plateaus after a while. So that's kind of what we see in these graphs. So let's see if our data, kind of what's happening here. So to really help us, we need to kind of see what's the difference between each of these different points in our data. And so we're going to go ahead and subtract each of them. All right, so if we look at the difference between our first two numbers, 346 and 1011, we know it's going up, but by how much did it go up? So if we subtract these, we get that it went up by 665. That's how much it went up. And if we look at between the next two, 1011 and 3455, it also went up, but went up by 2444. And then the next one, it also went up, but it went up by 6971. So right off the bat, is this a constant rate of change? Is the same thing being added the entire time? No, it's not. It's not a constant rate. So automatically I know it's not A. The A was that constant rate. And that's not what I have. I don't have something that's a constant rate. Now, is this the amount that it's going up by seems to be increasing rapidly. The difference, 665, that's like 4 times that is what I have on the next one, and then even more than that is what I have on the next one. So this seems to be increasing very rapidly, very, very quickly. It's a lot more every single time. It's going up very quickly, and so I would say with that data, when we can see kind of what's happening between, and we can even see it with the data that, I start out small, about 700 more. Oh, well, I'm now at 3,000. Oh, wait, it just jumped dramatically to 10,000. That would definitely tell me that my answer is B. My rate of change is increasing very rapidly. It is not slowing down. It is getting bigger every single time. So that's kind of what you would want to do with those type of problems, is look at the data, see which graph would match the data, what would make sense. And so let's just do one more with that, this problem right here. There will be 3 extra practice problems for you in the notes. We won't do that one together, but you will need to do those 3 by yourselves. We'll do this one real quick. So the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. So which graph could represent the data? So let's look. So our first variable here is the number of uses being used. So when it hasn't been used at all, there are 5 ounces of sunscreen. Well, after one use, it's gone down to 4.8. At another use, it's gone down to 4.6. At another one, it's gone down to 4.4. So right off the bat, we know our data is definitely going down. So let's look at our graphs to see if there's anything I can eliminate. So the first one, that's going down. So that's okay right now. The next one's going down. The next one's going down. So can't eliminate right now because they're all going down. If I look at the graphs a little bit more in detail, I can see, okay, this one's going down. It is a constant rate. So it looks like it's the same amount every time. Constant rate, but the rate is It's a big rate. It's going down by a lot every time. The rate of change is large or is big. Okay. This one, it looks like a little bit is used at first, but then a lot and definitely a lot all the way down. Another thing to note on the first one before I finish up that one, this last one ends at 0. So at this point, our can is empty. Okay, that's another thing to note. I come over here, and it says that at that point, I should be at 0. There should be no sunscreen left. So back to B, we see that our rate of change is changing. It's a changing rate of change, but it's changing very quickly. So very similar to what we said over here. It's a rapid, this one was a rapid increasing rate of change. This one in here, I would say, is a rapid decreasing rate of change. So it's the rate of change, the amount used every time is getting larger and larger and larger every time. Rapid decreasing rate of change. And then the next one looks to be constant again. Constant rate, and it's a very small rate. Okay, so that's kind of, we looked at our graphs, kind of discuss kind of what they look like. Now let's look back at our data and see what we actually have. So between the first two, from 5 to 4.8, all that it's been used has been 0.2 ounces. That's all that's gone down, minus 0.2. Look, the next one, 4.8 to 4.6, it's also minus 0.2. The next one, 4.6 to 4.4, is also minus 0.2. So that, since they're all the same, is a constant rate of change. That is a constant rate. So automatically I know it's not B. B, the rate of change was getting larger every single time. It's a change in rate. So no, it's not B, it's constant. But I have A and C that are both constant, so let's look back. This rate of change is very small. So do we think it's going to be the large rate of change, the big rate of change, or the small rate of change? The small rate of change. So C would be an answer. Another way to note, as I mentioned down here, that last point indicates that our bottle should be empty. Is our bottle empty at the after the third usage? No, still 4.4 ounces in the bottle, so it should not be empty. That's another way that we can see that nope, A is not the answer, but C is. Okay, so that is how we're kind of relating our variables in those graphs. All right, so again, you have 2 or rather 3 problems here that you will want to get done in your notes.